Good afternoon, everyone. This is Mr. Adamson. We're going to talk about renaming fractions, simplifying fractions, just a little bit extra of an explanation of what we were talking about in class. What's going on behind the scenes here is, let's take for example, hey, here's a rectangle, and part of this rectangle happens to be, have a fourth of it shaded, so I'll cut it into fourths. So there's roughly fourths, and this part of it is shaded. Now this fraction would be 1/4, but I could also give it another name if I wanted to. I could take these fourths, if I cut all of them in half, I now do not have fourths, I now have eighths. And how many of them are shaded? Well, that would be 2/8. And I did not change the shading at all, so these have to be equivalent. They have to be the same size. 1/4 has to be the same thing as 2/8. What if I went through and cut all these eighths in half again? So now I wouldn't have eighths, I would now have 16ths. And how many of them are shaded? Well, 1, 2, 3, 4. 4 of them would be shaded. And this could go on forever like this. So if you take a look at page 1, here's a couple of the sample problems. For example, number 1, 5, 6. Directions say something like, give two equivalent fractions. You can do anything you want to a fraction, so long as whatever you do to the top, you do to the bottom, and vice versa. Whatever you do to the bottom, you have to do to the top. So I just feel like multiplying by 2, so I will. I'm going to start here, and I'm going to multiply the top by 2. I'm going to multiply the bottom by 2. Could have multiplied by 3, 4, 5, 10, whatever, so long as whatever happens to the top must happen to the bottom. Okay? So 5 times 2, that is 10, and 6 times 2, that is 12. Oh, so this is equivalent. 5, 6 is the same thing as 10 twelfths. Now, I need to give two equivalent fractions, so I need to do this again. I could multiply by anything, and just because it's easy, I'm going to multiply by 10. It's easy to multiply by 10. Whenever you do, all you have to do is just add a 0 at the end. So 10 times 10, that is 100, and 12 times 10, that's 120. All three of these fractions, 10 100ths, 10 twelfths, 5 6, all of these fractions are the same. They're all equivalent. Drop down to number 5, 3, 6. It says, hey, give this another name. So there's a couple different ways we can do this. Alright, so these actually are both factors of 3, so I am going to divide by 3. Excuse me, they're both multiples of 3. I'm going to divide both the top and bottom by 3. Don't have to, you could have multiplied, but I'll divide by 3. So 3 divided by 3 is 1. 6 divided by 3 is 2. 3 6 is equivalent to 1/2. And now I have to do it again. I could divide. You could have decimal fractions or fractions. That's for another day, though. It's incredibly complicated. Don't worry about it. Let's just stay with nice, easy whole numbers. So here, instead of dividing again, I'll multiply. And I'll multiply by 7. Why? Because I feel like it. So multiply by 7. Multiply by 7. 1 times 7 is 7. 2 times 7 is 14. And all these fractions, 3 6, 1/2, 7 14ths, they are all equivalent, because whatever you do to the top, you have to do to the bottom. Whatever you do to the bottom, you have to do to the top. Alright, here's another problem on that same page 1 assignment, 56 64ths. Now, what we're trying to do here is simplify this fraction down. We're looking for common factors, and we're going to pull those common factors out. Now, looking at these two numbers, I can see that they are both even, so I definitely can divide by 2. So I'll do that. Alright, whatever you do to the top, you have to do to the bottom. So I'll divide the top by 2 and divide the bottom by 2. 56 divided by 2, well, let's see, 50 divided by 2 would be 25, 6 divided by 2 is 3, 25 and 3, that must be 28. Alright, 64 divided by 2, that is 32. All right, now up. These are both still even. So again, I will divide by 2. Okay. So 28 divided by 2, that's 14. 32 divided by 2, that is 16. Both still even. I can do it one more time. So I'll divide top and bottom by 2, and I'm going to end up with an equivalent fraction of 7/8. So 7/8 is the same thing as 14/16, the same thing as 28/32, same thing. All of these fractions are equivalent. They're just different names for the same quantity. Now it's common practice in math to give the simplest name, and the simplest name of this fraction is 7/8. Now you're thinking, wow, that was tedious. There's got to be a quicker way. There is. We're going to look for a common factor. So same problem, 56/64. Okay. I could, if I wanted to, check the prime factor chart, or I could break this down. But either way, eventually what I'm going to see here is that 56 is 2 times 2 times 2 times 7. And the 64 is 2 times 2 times 2 times 2 times 2. So I'm looking for common factors here. Actually, it's a 6 to the 6th power. So I'm going to remove these 2's. I'm going to remove these 2's. I'm going to remove these 2's. So this is 7 left on top, and then 2 to the 3rd power. Well, that is 8. So here's a faster way to do it. 56/64 is the same thing as 7/8. Even quicker way, hey, this is a multiple of 8. This is a multiple of 8. So if I just divide top and bottom by 8, I'd end up with 7/8. All right, and last one, I need to simplify this fraction. So I can divide by 2. They're also both multiples of 4. 12 is a multiple of 3, but 16 is not, so that won't work. So if I just look for common factors, I'll look up at the prime chart table and I see that 12 is 2 times 2 times 3, and that 16 is 2 to the 4th power. Okay, so I'm looking for common factors here. I see a 2, I can remove that. I see a 2, I can remove that. I'm left with 3 over 2 times 2, which is 3 to the 4th power. Simpler way to think of it, hey, 12/16. Those are both multiples of 4. Divide by 4. Divide by 4. 12 divided by 4 is 3. 16 divided by 4 is 4. Boom.